All right, so in trying to fill out these blanks, okay, and this is kind of the beginning of 3.6, relationships of f prime, and f double prime, we're not using new information. We're using all the same information that we've gone through in 3.3 and 3.4. And some of these are going to be a little bit more intuitive, and some of these are going to be not as intuitive, and I'm going to give you a strategy to help you with those. But like the first two, you needed this just to do your quiz. So when f is increasing, what does that tell us about f prime? It's positive. Okay, and here's a word bank. We may not use all of these words, but we'll use a lot of them. Okay, so then likewise, f is decreasing, f prime is negative. You needed that to do the quiz you just took. Okay, what about when f of x has a max or min? This one's a little bit harder. What's happening with f prime? It changes signs. So what some people might want to say here is 0 or undefined. Now, that's not a bad place to start. When f of f prime is 0 or undefined, that is a possible max or min, but we really need a change in sign to be ensured that we have a max or a min. And that's what this arrow goes both ways. So it's like an if then and then the converse of that. Okay. This next one is not as intuitive. F has a point of inflection. What is f prime doing? So we're going to skip that one for the time being. F of x is concave up. What is f double prime doing? Yeah, this is what we did Thursday and Friday. So when f is concave up, what is f, the second derivative? So this would be another positive. Okay, I heard a few things, so let's kind of unpack this. The second derivative is what tells us about concavity. When the second derivative is positive, f of x is concave up. Beyond that, it could be a horizontal tangent. It could be a relative max or min. Well, in this case, a min. But what I know for sure is that the second derivative is positive. So what does that then tell us goes in the next blank? Negative. Okay, the second derivative describes the concavity or the curvature of the graph. Okay, meaning is it curved upwards or curved downwards? Okay, what about the next one? F of x has a point of inflection. That's a change in concavity. So what we're talking about here is f double prime is changing signs. Again, 0 and undefined would not be a bad place to start, but you have to have a change in sign. If you get one of those sign charts where it goes plus, then plus again, that's not a point of inflection or a max or min, depending on whether you're analyzing first or second derivative. All right, and then beyond this, it kind of gets a little confusing. So I'm going to show you a little thing up here, and different calculus teachers use this in differing amounts. I use it a little bit, just a little, because I really want you to understand. I don't want you to memorize a trick, but sometimes it gets confusing, and we need a little trick to help us get by when we forget something. So what you're going to do, you're going to write f prime, f double prime, and in the f row, you're going to write plus, minus, and then you're going to go increasing, decreasing, concave up, concave down. All right, now there is a, by the way, if you have friends at another school or you have a tutor, there's a much larger version of this, and I'm just showing you kind of the short version of it. Okay, for f prime, we're going to do something similar, but we're going to skip over the first two, and I haven't yet really explained what this means. But you're going to do plus minus again, and then increasing and decreasing. And make sure your things are lined up vertically like how mine are. And then for f double prime, we're just going to do plus minus. Again, there is a larger version of this. I'm just doing kind of a short version. Here's what this means. Okay, when f is positive or negative, that alone does not tell us anything about f prime or f double prime. When F is positive or negative, that just tells us the Y values are either above or below the x-axis. When F is increasing, we do know that F prime is positive. I don't know if F double prime, though, is whatever. Okay, you could have it either way. When F is decreasing, F prime is negative, and again, I don't know about F double prime just based off of that. Okay, the last two have to do with concavity. When F is concave up, F prime is increasing, and I'm going to circle these two right here because these are the least intuitive for some people. To get that when F is concave up, that means F prime is increasing and F double prime is positive. There's a relationship here between three different things, and that, again, that can be confusing. When F is concave down, likewise, F prime is decreasing and F double prime is negative. So some of this you kind of just have already internalized. Some of this you haven't yet. That's where the chart will help. Okay, here's another way the chart helps. You can see here where we have an increasing to decreasing, we call that a relative max. When a function changes increasing to decreasing, that is a relative max. That means F prime has changed from positive to negative. All right, now because I've used the shortened version, we don't have the relative min on here, but you can kind of figure it out. If these two were switched, then so would the two signs be switched. Okay? Over here, what do we call that point where we change concavity? A point of inflection. Okay, so on a point of inflection, F prime could be changing from increasing to decreasing, or a relative max, and it would actually work the other way as well. So like if you had a concave down and then concave up, this would work as well. Okay, and then we have a sign change here for F double prime. So again, if you're like really into this, you may want to know the longer version, but I don't know if it's necessary, but what I've circled here, that's going to be important. So we can see this now. When F has a point of inflection, what is F prime doing? Well, a point of inflection is going to occur right there, right between a concave up and concave down. So what is F prime doing? A relative max in this case, but it could also work with a relative min. So that's what we're going to write here. Relative max or min. Okay, what about when F prime is increasing? So this is another reason why the chart may help. When F prime, don't go to positive, go to increasing. When F prime is increasing, F is concave up and F double prime is positive. And so this says F double prime, so I'm going to put a plus there. So we use the chart when it's not as intuitive. So what do you think should go in the next blank? Yeah, negative. When F prime is decreasing, that's technically F is concave down, but what F double prime is doing is being negative. Okay, what about when F prime has a max or a min? And just so I don't have to keep scrolling up or down, I'm going to rewrite the little chart here, and if you want to, that may be helpful because the more you write this, the better it will serve you. Okay, so when when F prime has a max or a min, on F, that's a point of inflection. On F double prime, that's a change in sign. So here's another change of signs. It's not enough to put 0 or even undefined here. We have to have a change in sign. Okay, this one is actually kind of weird, and we're just going to cross it off. It's not going to come up again. There's something we could do with it, but we're just not. We're just going to move on. What about when F prime changes from negative to positive? What is F of X doing? Well, if we look at our F prime row, I see a change from positive to negative, and that's a relative max on F. So that's actually what should go in the next blank, a relative max. Okay, so when F prime changes from positive to negative, that would be like increasing to decreasing. That's a relative max. That's what the chart tells us. So what do you think should go in the previous blank that we skipped? Relative min. Okay, when it changes the other way, it would just be a decrease and then an increase. That creates a relative min. So you don't need the chart, but it could help you here. What about when f prime has a max or min? Okay, so we look in the f prime row, and I can see that's happening right here. Well, what does that mean is happening for just plain f of x? A change in concavity, and what do we call that? Point of inflection. Okay, f double prime changes positive to negative. That's what we have right here. Okay, f, we would call that a point of inflection, but what do we call it on f prime? What do we call it when a graph changes from increasing to decreasing? A relative max. We could say extrema. In this case, we can be more specific. And so the other one then would be relative min. Okay, the whole point of this exercise is not so you memorize all of this. You're not going to memorize it, okay? You just need to have a strategy moving forward so that if I give you information about f and ask you about f prime, okay, well, we've already been doing that. But what if I give you information about f prime and ask you about f? That's a little bit harder to do, and that's what we're going to do in 3.6. So I'm actually not teaching you anything new. We're just basically using what we've done before to kind of answer new types of problems. Okay, we might only get through this first problem, and that's okay. We'll finish what we don't get through today, we'll finish tomorrow. All right, so we have a function. It's even. That just means it looks the same on the left as it does on the right. It really doesn't mean much for what we're going to use this for. Continuous, closed interval, that's all good stuff. Okay, and then we have a table. And sometimes tables can be scary, but on this problem, it actually makes everything easier. Okay, and they flat out tell us what's positive, what's negative, what's zero, what's undefined. So in A, it says find the x coordinate. So my answer is going to be x equals something, where f has an absolute max and an absolute min. Okay, this can be pretty tough, but go down just a little bit. Aren't we going to graph this? Then we can just look at the graph and figure it out. So we're going to actually skip part A. We're going to do that last. And this is like a pretty common thing on the AP test where they list this to find first. And we could find it, but it's going to be much easier if we just do it last. All right, look at B and C and D and E and all that. I ask you about something and then I say justify your answer. So what I would like for you to do is to go ahead and put a bunch of becauses in here. And actually what we're going to do is we're going to fill in the justification, and that's going to help us then find the answer. So for part B, over what interval is the graph of f increasing, what would our justification be? And I'll help you out here because f prime is positive. So then what you do is you go to the f prime row and you pick out positive and you write that interval down, 2 to 3. So this is what I meant by easier. We're not algebraically, we're not finding the derivative and solving for x. We don't have to do that here. Okay, what about C? What would the justification be? Because f prime is negative. So again, look in your f prime row, pick out the negative intervals, so 0 to 1, and then also from 1 to 2. By the way, if f prime is negative, 0, negative, is there a relative extrema happening at x equals 1? No, because there's not a change in sign. It doesn't go from negative to positive or vice versa. Okay, D, concave. That's telling me, let's start thinking about second derivative. So concave down would be the second derivative is negative. So now we're going to not look in that row, we're going to look in the last row. So where is the second derivative negative? 1 to 2 and also 2 to 3. Okay, try to do E on your own. Okay, what'd you guys get? 0 to 1, because f double prime is positive. All right. Before we get to the graph, last thing, find the x coordinate of each point of inflection. So what would the justification be here for point of inflection? That's talking about second derivative. So what should we say next? Because f double prime changes signs. So we got to look here. Where does f double prime change signs? Only in actually one place, x equals 1. That's the only time it actually changes. Okay, so there are other things I could have asked about relative maxes and mins, and you're going to get your chance to kind of practice those in this worksheet. It's all pretty much the same. Write the justification, then go to the table and look it up. All right, now in order to do the graph, the first thing we want to do is see if we have actual points. And this table gives us these points. I haven't talked much about it yet, but this f of x, that's the y value. So when they're saying when x is 0, f of x is 1, they're saying the point 0, 1 is on our graph. So let's go ahead and do that. 0 to 1, 1, 0, and 2, negative 1. And then what we need to do is between 0 and 3 is fill in with curves. We need to know increasing, decreasing, and concavity. All right, now one thing that I think could be helpful is to actually graph, like see where it says f prime is negative, like actually put a decreasing arrow like that and an increasing arrow for positive. Likewise, like actually doing a concave up piece for positive and a concave down piece for negative. This is just a strategy to help you with the next part. So from 0 to 1, the y values are positive, decreasing, and concave up. So when I'm connecting these two, obviously the y values are positive. That makes sense just connecting the two. Obviously I have to decrease. The concave up is the part you got to focus on. And you need to make sure there's some curve to your graph and it's concave up. In fact, if you think about a circle that's been sliced in half twice, you have options like this. That's what all your pieces should look like. One of these. So that can kind of be a guide. So I'm not going to scroll up, but from 1 to 2, it says my y values are negative, decreasing, makes sense, and concave down. So I wouldn't do the same thing I just did. I need to flip this and make the curve go that way. This is going to take a little bit of a practice. Highly recommending pencil instead of pen on this. Okay, from 2 to 3. My y values are negative, so I need to stay below the x-axis. Positive, which means increasing, so I can only increase a little bit. And then a negative, so I need to do a concave down piece. And I stayed below the x-axis because the table said my y values are negative. Okay, so this is a sketch. What's happening at x equals 2? It is a relative min. It is a cusp. So is it a point of inflection? We have concave down and then concave down again. So on that cusp though, what should f prime be? Undefined, right? And it was. That's why these were undefined right there. Okay, so it all is going to match up. If you, after your graph, look at the table and have something that doesn't match up, you need to fix it. You need to go back and say, okay, well, this either was a bad problem or I messed up. Okay, so we said we were going to do A last. And so by just looking at your graph, you should be able to figure out the absolute max and the absolute min. Now, they only want the x coordinate. So I'm gonna give that. And if I scroll, I hate scrolling back up and down again, but you can kind of see the max is happening at x equals 0, the absolute max, and then the absolute min is happening down here at also a relative min. So x equals 0 and x equals 2. Much easier to do at the very end. Now, if your graph's wrong, your absolute max and min could be wrong. So you do have to watch out for that. I don't want to do the next problem, but I want you to we're just going to look at it really quick. We're not going to do a whole lot with this. How is this problem, though, different than the one we just did? There was no table. It's a graph. And what is this the graph of? F prime. I want you to put a big F prime there. That's, okay, before I would give you a graph of F and ask you lots of questions about F. That's pre-cal, actually. Calculus is given F prime, which is a little weird, now answer questions about F. So when I'm asking you over what interval is F decreasing, I'm not asking you to look at this picture and tell me where this picture is decreasing. We're beyond that. I'm asking you to make the relationship between F decreasing and what F prime should be doing. Okay? So one little thing here, though, is interesting. Look at the justifications. It says justify all of your answers in terms of F prime. All right? So our justifications on all these should be because F prime, blah, blah, blah. Because F prime, blah, blah, blah. Okay, we're going to finish this tomorrow, though. And